Okay. We are going to go over the review activity that we did in class today. And here it is. So this is unit conversion and dosage calculation. This is something that you're really going to need. And so you can kind of read through. I'm not going to read the text to you, but what I want you to do at every point that I'm about to do something, I want you to pause the video and I want you to try to answer the question without my help. So the first thing is just to look at the units and to know which ones are customary units that we kind of use in common language, but aren't metric, aren't the standard units, and then which ones are metric. So go ahead and pause the video at this point and go ahead and try and do that. And so I will go ahead and do this. Let's see. Ooh, that's not a whole lot of room. Okay, we're going to pause it right here. Let's see if I can pause. Okay, so there was too much room to do that. So what I just did was, you should have answered this for yourself first, is copied and pasted them in. So the customary unit for mass right here, mass is pound. The metric unit is gram. So just to know what's metric and what's not is really important. And you're going to do a lot of pounds to grams in science. Volume is our fluid ounce versus the liter. Length is inches versus the meter. Energy is calorie, and I don't really like how they did it here. This should have been the big C. Looks like a little C, but it should be the big C, that nutritional calorie, when you're talking about customary units, whereas in metric, we do that in joules. You could have also said the big C over here in metric unit. That would have been okay, but it wasn't one of the choices. Temperature was Fahrenheit in customary, and temperature in science is either Kelvin or Celsius. They just didn't give you Celsius here. And then the last one, pressure. If you're checking the pressure of your tires, oops, you are looking at pounds per square inch. But if you're doing the metric unit, why did I put meter? That's funny. I did it again. That's fine. Okay, it's not meter. It is Pascal. I can find it. P-A-S, Pascal, P-A, okay? And that is the metric unit. So now that you kind of know what the units are, it's really important to understand what we can do to those base units. If we add a prefix to the base unit, that changes the meaning of the unit by a power of 10. So let's not worry about the numbers just for a minute. So if we look at our base unit, let's say that our base unit in this case is liters, right? So we're going to pick that liters. And so here's my big L. If I take that liter and I convert that liter to a deciliter, so a deciliter, what's happening? Is that unit of measurement getting bigger or smaller? Well, that's kind of hard for me to think about, but I know like a liter of Coke at the grocery store, I kind of know how much that is. And then the one that you're probably pretty familiar with is a milliliter. So a lot of times you're going to see this in the medical field, a milliliter. You know about how much a milliliter of something is. It's pretty gosh darn small. So you could have a lot of milliliters that are put together to finally add up to a liter. And how many of those milliliters would you have to put together to get to a liter? Well, that's what this number over here is telling you. It's telling you that you would need 1,000. So using this chart, and this chart is the exact same chart that's on your best friend. So you're going to have this on an exam. So anything in this chart that is below the base unit, what's going to end up happening is that you're going to get smaller. So when we go from that liter, when we go from the liter to the deciliter, we're getting small, right? So we're getting small. Centi, we get even smaller. So smaller. When we get to milliliter, gosh, that's even smaller, even smaller. And when we get to microliter, oh my gosh, that is the smallest, right? And so that is micro, or MCL, microliter. So every time we go from liter to deciliter, we go small. We go from centiliter, then we can go to all the way down here to microliter, okay? So every time we do that, we get smaller and smaller and smaller and smaller. And by how much, you have that number on the side here that tells you how much smaller. So I can use this little table to create some equivalent equations, okay? So if I was going to compare a deciliter to a liter, I want to know how many deciliters are in how many liters. Well, which one's going to be bigger, a liter or a deciliter? Should have said deciliter, right? Because we said if we go from a liter to a deciliter, it gets smaller. So how many deciliters does it take to make up 1 liter? Well, that's what this number is telling us. There are 10 deciliters in every 1 liter. Go to the next one. Go to centiliters. How many centiliters do you need in order to get to 1 liter? You would need 100 centiliters. Do it again. Go to milli. How many milliliters would I need? Oh my gosh, now I need 1, 2, 3, 1,000 milliliters in order to equal to 1 liter. Keep going to micro. Oh my gosh, we need even more. We need 1,000 million, a million microliters to equal to 1 liter. So as we go down the table, that prefix says it's an even smaller and smaller and smaller amount. And I know that it's getting smaller because when I look at each of these, I can see that they all have this division sign, and that tells me that it gets smaller. If I look above my base unit, if I go up from liter to kiloliter, now I have to multiply by 1,000. So that's telling me that a kiloliter is huge compared to a liter. So now I'm kind of going to have to rearrange that. I'm going to have to say in 1 kiloliter, I have 1,000, that's what this number is telling me, liters. So it's really important that you understand this table so that you can use it well. So what do you notice about every single one of these relationships we did in this column here? If you look at the equivalents, what's bigger, a kiloliter or a liter? My kiloliter is bigger. The bigger value is going to get the 1. The smaller value is going to get whatever's here, okay? And it works for all of them. So let's do it again for the next one. Deciliter and liter, which one is bigger? A liter is bigger than a deciliter, so the 10 goes to the smaller unit. Do the next one. 100 centiliters is equal to 1 liter. What's smaller, liter or centiliter? Centiliter smaller, so the bigger one, the liter, gets the 1. The smaller one gets the 100. Next one. What's bigger, liter or milliliter? Liter is bigger, and then the smaller unit gets whatever's here. So that's 1,000. What's bigger, a liter or a microliter? Liter or a microliter? A liter. And so the smaller unit gets that value. So that's how you know how to make these equivalent relationships. And these equivalent relationships are going to be really, really important. So I'm going to try and leave them and kind of clean up just a little bit so that it's easier to look at. Got so much going on. Okay. All right. So now, what is smaller? And we kind of already answered this. And every time you get to a question, pause it before I give the answer. Attempt it, then press play. So which is smaller, a gram or a kilogram? It is a gram that is smaller. What is smaller, a milliliter or a liter? A milliliter is smaller. Okay. Now we have to start using these equivalent relationships. So we have soft drinks that are sold in 2-liter bottles. How many milliliters of a soft drink are in 2 liters? You should look at that and go, yes, that's a dimensional analysis or a unit conversion problem. So there's a little pathway that I want you to take when you solve these kinds of problems. It's a 3-step method. The first step is to find and write your goal unit. So for this one, what's my goal unit? My goal unit is how many milliliters of the soft drink are in 2 liters. So my goal unit is milliliters. My second step is to pull out important, important mathematical relationships. Slash values, right? Something with numbers inside of our problem. And so sometimes they'll give you lots of information, like when we get to dosage calculations, and sometimes it'll just be a little bit. So here, the only other information that I'm given is that we're starting with a 2-liter bottle, right? How many milliliters of soft drink are in 2 liters? So the only thing here I have is 2 liters. Then the third one is to set up your dimensional analysis. And I'm going to show you how to do that. So we have our goal. We know where we're going. We know what information we have. Now we need to set it up. So sometimes you have to pick what to start with, but since we only have one thing, that's what we have to start with. So we're going to start with 2 liters. And I'm going to set up my fence post because I know I'm doing dimensional analysis. So if I'm trying to get away from liters and get 2 milliliters, because that's my goal is milliliters. If liters is in the top, in order to get rid of it, I have to put liters on the bottom. But the only way that I can really get rid of liters is if I put something that's equivalent on top. So I want you to kind of think about this. I'm going to pause this for just a second. If I have a fraction that's 100 divided by 100, really the numerator is exactly the same as the denominator. So they cancel one another out, and so you end up with 1. And that's exactly the same thing that we're going to do. If we have something that's liters and we want milliliters, well, here we have liters and milliliters. That's a relationship we have up here. I can take that, and I'm just going to recopy that down here. So I have 1,000 milliliters equal to 1 liter. I'm going to take that and I'm going to turn that into a fraction. And I can do it in one of 2 ways. The first way is I could put milliliters on top. The second way is I could put milliliters on bottom. These 2 fractions are actually the same thing because 1,000 milliliters is equal to 1 liter. Those 2 things are equal to one another. So actually they cancel out, and that's 1 over 1. Same thing here. They cancel out. It's 1 over 1. So all we're really doing is multiplying by a fraction that is equal to 1 in order to get rid of units we don't want and introduce units we do want. So in this case, we want to get rid of, let me kind of erase these lines. We want to get rid of our liters. So that is why over here, we put liters on the bottom. So because liters are on the bottom, what do we want on the top? We want the new unit that we're going to introduce. We want that to be milliliters. So I go back here and I say, okay, 1 liter is equal to 1,000 milliliters. And I can see that my liters, if I have it on the bottom and I have it on the top, they cancel out. So now I'm left in the units of milliliters, which is great. And all I have left is to do the math. 2 times 1,000 milliliters is equal to 2,000 milliliters. And that gets me exactly my goal. I always want to check, did my unit and my goal unit match? Yes, I'm very, very happy. The other thing you need to check is your significant figures. I have one significant figure here. I have one significant figure here. So I am good. Okay. We're going to try the next one. And oh, hold on, y'all. Okay, so for our next one, I'm going to have to kind of erase what we have written down here. Now, the U.S. recommended daily allowances values for the vitamins A and E for adult women. So for A is 700 micrograms mcg per day. And for vitamin E, it is 15 milligrams per day. How many micrograms are present in 15 milligrams? So that's part A. So part A is a dimensional analysis problem. So just like we did before, what's our goal? Our goal unit is to get to micrograms, so mcg. And then what do we know? That's the second part, is we know we're starting with 15 milligrams. That's it. That's the only thing they've given us. This 700, it's not part of the question. Like, yes, it's information, but it's not part of what we need to answer for A. So make sure that you're just pulling out what you need. So we're going to set up our third step is set up our 10th post, our dimensional analysis. So we're going to start out with 15 milligrams. Now, what do we want to get to? We want to get to micrograms. So we have to get rid of milligrams. If milligrams is on the top, we put milligrams on the bottom. Now, if I look up here, do I have some kind of equivalent relationship here in this group here that shows milligrams to micrograms? And the answer is no. There's more than one way to skin a cat. You know, I love cats, but there's more than one way to skin a cat. So there are other ways to do this, but I'm going to recommend that you always go to your base unit. And that way you don't make some simple mistakes that happen. So what I can do is I can go from, if I have milligrams and I want to get to micrograms, what I can do is I can go from milligrams to my base, that's a gram, and then go from the gram to the microgram, because I know all of those relationships. So let's see if we can do that. What relationships might we need to know? Well, we're going to need to know that in the relationship between milligrams to grams, and that is milli is 1,000 milligrams in 1 gram. So I'm going to put that in and I'm going to say, okay, I want to get rid of milligrams. Milligrams is on the bottom. I'm going to introduce grams. Grams is on the top. And I have 1,000 milligrams in 1 gram. Okay, but grams is not what I want. My goal is micrograms. So I need to get rid of grams. I'm going to put grams on the bottom, and I want to introduce our micrograms. So if you go back up to your table, here's our micro equivalents, and we're just going to change those liters to grams. So I have 1,000,000 micrograms in 1 gram. So I'm going to use that relationship, and I'm going to say in 1 gram, I have 1,000,000. I never give myself enough room. 1,000,000 micrograms. And so what you can see is you can plug this into your calculator. You can do 15 times 1,000,000 divided by 1,000. Just make sure that you put this top portion in parentheses. And if you had more than one thing in the denominator, you also put that in parentheses in your calculator. But what you could see is that these 3 zeros cancel with these 3 zeros, and you get 15,000. And be careful with your units. Our grams canceled. So what are we left in? Micrograms, mcg. Okay, so that would be our final answer. Okay, so this was kind of part of the above. All right, so which vitamin is needed in higher amounts daily, vitamin A or vitamin E? Well, we see from the initial problem that A needed 700 micrograms per day. E needs 15 milligrams per day. I can't do that perfect comparison because milligrams and micrograms is different. But what I just did in that problem is that I converted my milligrams into micrograms. So knowing that, I can now convert 15 milligrams to 15,000 micrograms mcg per day, right? So now which one's bigger? Well, obviously here, our vitamin E we need more of in higher amounts. So just keep practicing and keep following that method. So this is some additional dosage calculations, but if you go to your best friend, you know, here's our best friend. We know that we have lots of these same conversion factors here in our best friend that we can use. So I would say always go to your best friend to look for conversion factors. And everything we talked about is kind of in there. Okay, so here, a visitor from Europe knows their weight to be 75.2 kilograms. How much does a person weigh in pounds? Well, do your step by step. Number one, what's my goal? My goal is how much does a person weigh in pounds? My goal unit is pounds. And a lot of times I like to write pounds in cursive, the L in cursive, because then I know it's not a 1, that it's an L. Okay, the next thing is to pull out information. What information do we know? We know 75.2 kilograms is how much the person weighs. And I know I'm going to have to go from kilograms to pounds. So I want to go and I want to look on my best friend. And here's this little category that has some mass information that you can use. So here I have this nice little conversion factor. I'm going to write it on my page here. 1 kilogram is equal to 2.20 pounds. So now I kind of have all the information I need to start my problem. So I'm going to start with what I know. What I know is 75.2 kilograms is how much the person weighs. And I want to go from kilograms to pounds. So if I want to get rid of kilograms, kilograms goes on the bottom. And I have this relationship here where I know the relationship between kilograms and pounds. So I can do that. And I can say in 1 kilogram, there are 2.20 pounds. So now if we put that into our calculator, what should we get? You should get 165 pounds. And you should always kind of be looking at these problems and does that kind of make sense? Is it normal to have a 165-pound person? Sure. Okay, a friend of yours is running in a 10-kilometer race. How many miles is he or she running? So what's my goal? My goal is I want in my units in miles. And then what do I know? I know that they're starting a 10-kilometer race. Okay, so I'm going to start with what I know, 10 kilometers. And I know I'm going to want to get rid of kilometers and I'm going to want to go to miles. So let's see if we can find a relationship here in length, because miles and kilometers, those are all length measurements, that relates kilometers and miles. And so here I can see I have this relationship between kilometers and miles. I know 1 kilometer is equal to 0.621 miles. So all I have to do is plug that in and say 1 kilometer is 0.621 miles. My kilometers will cancel. I'm left in the unit that I want, miles. And so 10 times 0.621 is 0.621 miles. The only other thing I need to worry about is sig figs. Here I'm starting in only 1 sig fig. Here I have technically 3. So this would be 6 miles, right? Technically, a 10-kilometer race is technically a 10-point-kilometer race because it's that precise. So if you also gave 6.2 miles, that would be fine. But you know, on an exam, I'll make sure that that's correct. Okay. The next one, this gets into the really important stuff that you're going to deal with on a daily basis. So a mother is to give her child 10 cc's of a medicine every 4 hours. Unfortunately, she lost the syringe, just like we talked about in class, that came with the medicine. She calls the clinic for help. How much medicine can you instruct her to give the child? So the first thing we want to know is the goal. What's the goal? We're trying to get to teaspoons, right? Because she's lost the syringe. So what is she going to do? She's going to use whatever volume measurement she has in the house. Most people are going to have teaspoons. So our goal is teaspoons. What do we know? We know that she's starting with 10 cc's, and we know that she's going to give a dose one dose every 4 hours. Okay. So what do we start with? We start with 10 cc's. Can I go straight from cc's to teaspoons? I don't see that conversion in my best friend. So what I do is I look for cc's. Here's something with cc's. Would I want to go cc's to mils or cc's to centimeter square? I want to go cc's to milliliters, because once I have milliliters, then I can go from milliliters to teaspoons. So you just got to look for those common units. So I'm going to put cc's on the bottom over here so that cc's cancel. And I'm going to use this top one first over here. And I'm going to say there's 1 cc for every 1 milliliter. Okay. But I don't want to be in milliliters. I want to be in teaspoons. So I got to put milliliters on the bottom. My milliliters cancel. And now I'm going to use this bottom one right here. And I'm going to say that there are 5 milliliters in every 1 teaspoon. So again, my unit that I want to cancel out has to be opposite. And then I'm going to introduce a new one to get to my goal. So now I end up 10 times 1 times 1 gives me 10. 1 times 5 gives me 5. And then I'm in teaspoons. So 10 divided by 5 is 2 teaspoons. So how much medicine can you instruct her to give the child? 2 teaspoons, give the child 2 teaspoons of medicine every 4 hours. And that's your dose, right? She's giving a dose every 4 hours. Okay, let's try another one. A physician orders a dose of 250 milligrams of an antibiotic 3 times a day. Medicine is available suspended in liquid as 125 milligrams per 5 mils. The patient only has a teaspoon available for administering the medicine. How many teaspoons will the patient need to take each dose and each day? Wow, that was a lot of information, right? Probably feeling overwhelmed, but you're going to go back to that 3-step method. So step number 1 is to find your goal. What's my goal? I actually have 2 goals this time. So my first goal is I want to know how many teaspoons per dose. So teaspoons per dose. Then the second goal that I have, and I guess I should do this like A and B, so we don't have all those numbers. And then the second one is each day, but each day what? I want to say how many teaspoons will the patient need to take each day? So this is again teaspoons. So here I know my goals. Now you need to start pulling out information. So what do you know? Well, I know that the physician ordered a dose of 250 milligrams of our antibiotic 3 times a day. That's technically 3 little pieces of medicine, because the doctor is telling me that I need to give the patient 250 milligrams of medicine every time it's a dose, right? So it orders a dose of 250 milligrams. So we could say that's 250 milligrams per one dose. Okay. Now, how often are we going to give this person the medicine? Well, we're going to give them the medicine 3 times a day, or 3 doses per day, right? So these are just, I'm just listing relationships that I know. What else was I told in this problem? I'll kind of erase some of this. I was also told that the medicine is available suspended in a liquid as 125 milligrams of medicine per 5 milliliters of solution. Okay. What else do I know? The patient only has a teaspoon available. Ooh, oh. Okay, so I know I'm going to need something with a teaspoon. And you remember that you had over here on your best friend this relationship between teaspoons and mils. And I know I have mils. Over here, I have milliliters. So I'm probably going to have to use something with milliliters. So I'm guessing that I'm going to need this 1 teaspoon in 5 milliliter relationship. Okay. All right. Now our third step is going to be to do the dimensional analysis. But you got all this information that you've pulled out. Where do you start? I typically start with what the physician orders. So the physician ordered 250 milligrams per 1 dose. So that's where I'm starting. I'm kind of going to draw this kind of long. Now I just got to get to teaspoons per dose and teaspoons per day. So how do I do that? So if I want to get rid of milligrams, because, right, let's do A first. Let's do that. I want to get teaspoons per dose. I'm in milligrams per dose. Well, dose is right. So I don't need to change dose. I only need to change my numerator from milligrams to teaspoons. So let's do that. If I want to get rid of milligrams, that's cool. Do I have anything up here? And kind of the other thing I almost forgot that I want to tell y'all is once you use something from the no category, I kind of cross it out just so I don't use it again. And I'm, eliminating all the things that I can pull. So now I want to get to teaspoons. I'm in milligrams. Do I see anything that relates milligrams to teaspoons? No. But what does have teaspoons in it? What does have milligrams in it? If this is the unit I'm in, I need something with milligrams. Well, the only other conversion factor I have that has milligrams is this concentration of the medicine. I have 125 milligrams per 5 milliliters. So I'm going to go ahead and use that. And I'm going to say, I'm going to introduce milligrams, and then I'm going to go to milliliters. So I just pull my information, 5 milliliters in every 125 milligrams. There we go. So my milligrams have canceled and I'm in milliliters. Well, that's nice, but that's not the unit I want. I want to be in teaspoons up here. I want to be in teaspoons. So I'm going to put milliliters at the bottom. Said I get rid of it. And then I've used that, so I need to cross that out. Now I want to go from milliliters to teaspoons. Look at that. I have this right here that is milliliters to teaspoons. So all I have to do is put in 5 milliliters, 1 teaspoon. My milliliters cancels and I'm left in teaspoons. That's fantastic, right? So now that equals to, let's see, kind of shorten that. Okay, so that equals to, we have 250 times 5, but look, this is one thing I like to do is I like to look at this and I like to say that's a 5 and that's a 5, so that cancels, right? So that's really easy. And then 250 divided by 125, that's just in half, so that's 2 teaspoons per dose. Now you don't have to do the math in your head. You can just put it in your calculator. That's cool. Okay, so this was my answer to part A. That was our goal, our very first goal. Now, we've gotten that, but we have to go in and we have to do B. So now I need teaspoons per day. Well, I'm in teaspoons right here. I'm in teaspoons. I want teaspoons. So that's great. I don't need to do anything with it. But what's different is the bottom, the dose. I need to convert from dose to day. So if I look at what I have left, right, I have this conversion factor right here that has dose in it. So let's see if we can use that. If I want to get rid of dose, I put it in the numerator. And then I want to go to day, and that's exactly what I have. So that's perfect. There are 3 doses in one day. So dose cancels, and I'm left with 2 times 3 is 6. What are my units? I'm left in teaspoons per day. And that's exactly what I was asked for in B, teaspoons per day. And if you look, our sig figs, 5 milliliters is 1 sig fig. So both of our answers are 1 sig fig, right? And so that's great. So we use these, and I just forgot to X them out. So don't forget to X them out. So this is just use the same pathway. Get your goal, show what you know, do your dimensional analysis, and you'll have this set path that you're always going to take. So don't forget to pause it and try these problems without me. All right, a patient gets 2 liters of dextrose 4% and 0.18% sodium chloride over 18 hours through an IV. Calculate the drip rate in drops per minute. I think you've seen in the book and homework that the unit for drops is GTT. So drops and GTT, same thing, per minute. So the drip rate in drops per minute. The IV delivers 20 drops per ml. So sometimes you'll see drops as GTT. Sometimes you'll see them written out as drops. Same thing. Okay, so what do? We do our goal. What's our goal? Our goal is to calculate the drip rate in drops per minute. Okay, what do I know? This is a dimensional analysis problem. So sometimes you see all of this junk. Does it matter what you're giving them? No. I mean, yes, it matters. The doctor prescribed a certain amount, but when you're calculating to change units, sometimes you have extra information that you don't need. So that what I've boxed in, I don't need. So I know that the patient should get 2 liters of this stuff over 18 hours. So that's one conversion factor that I know. And then it says calculate the drip rate. That's my goal. Then it says the IV delivers 20 drops per 1 ml. Okay. So then we set up our dimensional analysis. Start with whatever the doctor told me to give the patient. The doctor told me to give the patient 2 liters in 18 hours. Okay, so I'm going to X that out because I've used it. I want to get 2 drops per minute. I'm in liters per hour. Oof. So let's work first on the time part. So if I want to convert hours to minutes, if I want to get rid of hours, I put hours on the top, and I want to introduce minutes. So do I know the relationship between minutes and hours? Sure. I know in 1 hour, there's 60 minutes. So my hours cancel out. I'm left now in liters per minute. Well, liters per minute is not quite what I want. The minute is correct, but the liters is not. So I'm going to put liters on the bottom. Do I have anything that converts me straight from liters to drops? No. But what do I know? I know that in 1 liter, I have 1,000 milliliters. Then I can convert from milliliters to drops with this one. Okay, so let's use this relationship next. I know in 1 liter, I have 1,000 milliliters. And I can use my best friend to come here to find out. Here, milli is divided by 1,000. So that gives you this relationship right here. Okay, so we use that. So we're going to put an X on it. What happens to our units? Well, in this, our units, liters cancel with liters. Okay, so we're going to keep going because we're now in milliliters per minute, and that's not quite what we want. So we want to get rid of milliliters, and we want to go to right here, we want to go to drops because that's our goal. And lo and behold, I have this great conversion factor that I can use. I know there are 20 drops in 1 milliliter. So my milliliters cancel, and I just have to do the math. So put it in your calculator. 2 times 20 divided by 18 times 60. And so when you do that math, what you should get, and if you don't, it's all about you didn't put parentheses in, 37 drops per minute. Because the only units left were drops here and minutes here. All the other units got canceled out. So we used all of our knowledge and we got to our goal. We were very happy. And that kind of makes sense. 37 drops per minute. So that's like 1 every other second. That kind of makes sense. If you get a number that's way far wacky, just stop, go back. You did something wrong, right? Okay. You can kind of skip 1 and 2. These aren't dosage calculations. So we'll kind of save time. Those are not real difficult problems. You can do them if you want. If you want, you should get for the first one 0.95 miles. That's the answer. And then your final answer for number 2, if you give it in pounds and ounces, right, you're going to get something that is 7.63 pounds. And then you got to convert this 0.63 pounds to ounces. So then you get 7 pounds, 10 ounces, which is kind of a crazy way to have to do it. Metric would be so much easier. But anyway, okay. A children's cold medicine contains 10, that should be mcg, 10 milligrams, in milligrams, that must be milligrams. 10 milligrams, it shouldn't have an S, just 10 milligrams of pseudoephedrine hydrochloride per milliliter. A child is to take no more than 150 milligrams per day divided into 4 even doses. A mother calls you to say that she lost the syringe, imagine that came with the cold medicine. You need to advise her on how many teaspoons she should give her child per dose. So how many teaspoons should she give her child per dose, and how often each day she should give her the medicine? What do you tell her? Okay, so what is my goal? My goal is I need to know how many teaspoons per dose. That's one of my goals. Let me do a different color. Let's do red, right? So one of my goals is teaspoons per TSP, teaspoons per dose. And then my other goal is how often each day she should give the medicine. So the medicine is basically how many times a day. That's our other goal. So how often each day she should give the medicine. So it's how many doses per day is how often she should do this. Okay. Gosh, there's kind of a lot of information here. So start pulling out the things that you need to use. And I'll kind of erase the things that are up here so that I have some room to list some information. Okay. So the medicine contains, here's what I know. These are things that I know. I have 10 milligrams of pseudoephedrine hydrochloride per milliliter. That's something that I know. A child is to take no more than 150 milligrams per day. So 150 milligrams per day divided into 4 even doses. So what you're giving them in one day is 4 doses, right? And that's kind of all the information that you're given in the problem. But remember that she called you and she lost the syringe. So you have to think about teaspoons. So I'm going to go to my best friend and I'm going to go remember my teaspoon conversion. And I'm going to say, I know that in 1 teaspoon, I have 5 milliliters. Now I don't have to keep going back to that word problem. You want to avoid that. So where do you start? I start with what the doctor tells me. So the doctor says, don't take any more than 150 milligrams per day. So I used this conversion factor, so I'm going to cross it out. Now, my goal is to get to either teaspoons per dose or doses per day. So let's do the first one. Let's go to teaspoons per dose. So I'm in days. I want to go from days to doses. So I'm going to put day on the top. And I want to get to doses. Do I have a conversion factor that converts between days and doses? And indeed, I do. And it's this one right here. So I know in one day, I have 4 doses. So days cancels. And I'm in milligrams per dose, which is very close. So my dose is good. I'm worried about changing to teaspoons now. So leave this dose alone, and we want to get rid of milligrams over here. So we're going to put milligrams on the bottom, and we want to go to teaspoons. Well, I don't really have anything that gives me milligrams. I got to cross that out. I don't really have anything that gives me milligrams to teaspoons, but I do have this conversion factor for milligrams to milliliters. So let's use that. 10 milligrams in every 1 milliliter of our medicine. So our milligrams will cancel. We're getting closer. Now we're in volume. So that's milliliters. If I want to get rid of milliliters and I want to get to teaspoons because that's what the mom has. So I know I can use, I've got to cross that out. I know I can use this conversion factor and I can say 5 milliliters in every 1 teaspoon. And then all I have to do is plug it in. So 150 on the top, put it in parentheses, divided by 4 times 10 times 5 in parentheses. And what you should get is 0.75 teaspoons per dose. So it's really like 3/4 of a teaspoon per dose, right? And the other part is how many doses per day. Well, this is really easy. It just told you. You need it in 4 even doses. So you should give 3/4 of a teaspoon 4 times a day. Per day. Right? So that second one, you didn't really have to do the math one. You just kind of had to read. All right. A prescription for amoxicillin comes in an oral suspension. And let me just kind of get rid of all this stuff up above. I know that you can pause it and you can go back and copy it. So I'm just going to cut that out just to give me some more room. Okay. So a prescription for amoxicillin comes in an oral suspension, a solution that is, and I kind of, sometimes I cheat and I start putting the things that I know as I read it. But I have 250 milligrams per 5.0 milliliters, okay? So we have that oral suspension of our medicine, and the patient is prescribed 500 milligrams every 6 hours. What that also tells me is my dosage, right? How many hours are in a dose? So I know in 1 dose, that is 6 hours, right? So it's just another piece of information that I know. Now, what's my goal? So I kind of go back. I got out of order. So how many milliliters of amoxicillin should the patient take per dose? So my goal is milliliters per dose. That's not the only thing I'm asked. I'm asked how many teaspoons. Oh gosh, they ask for a lot of information. I'm just going to scooch that over. They're asking for how many teaspoons per dose. So TSP per dose. Then they're asking for how many teaspoons per day. So I kind of have three parts of this that I need to answer. So what do you start with? I start with what the doctor prescribed. The doctor prescribed 500 milligrams, and 500 milligrams every 6 hours. The other way that you could do this is you could say that that was one dose. Like some people skip ahead to that, and that's cool. But if you don't see it, I'm going to show it. So here I know that I need to get rid of hours and I need to go to dose. So I know that if hours is on the bottom, I want to put hours on the top so it cancels. I'm going to put dose on the bottom. I know that for every 6 hours, that's one dose. So my hours cancel and my 6 cancels. So you might have automatically seen that, and that's cool. If you didn't, it's okay. So I need to know how many milliliters per dose. So now I'm in milligrams per dose. So dose is good, but I need to convert to milliliters, and I am in milligrams. So if milligrams is what I want to get rid of, I'm going to put it on the bottom. And oh, I used this and I used this, right? Okay, so I'm going to put milligrams on the bottom. Didn't give myself enough room. I never do. 250 milligrams. So my milligrams cancel, and this is what I'm using. And I'm put 5.0 per every 5.0 milliliters. So I'm now in milliliters per dose, and that's exactly what I want to be in. So I'm going to do the math, and what you should get is 10 milliliters per dose. Okay, so that's my very first, we'll highlight it, that's our first answer to right here. Okay. All right, now I need to convert from milliliters per dose to teaspoons per dose. So let me just set up another dimensional analysis. I want to get rid of milliliters and I want to go to teaspoons. Well, what do I know? Go back and remember, just like we used in the last one, and just like we got right here, right? That in 1 teaspoon, we have 5 ml. So 10 divided by 5, that gives me 2 teaspoons. Whoops. 2 teaspoons per ml. Okay, so that was this one right here, teaspoons per dose. Teaspoons. Oh, I want teaspoons per dose. Look at that. So I am in teaspoons per dose. I just didn't follow my stuff. Y'all be careful. Be careful, be careful. This is why I always say cancel out your units. My milliliters canceled out, so I'm in teaspoons per dose. That's why I always check. Always, always, always check. See, everybody makes mistakes. Okay, so I've got the second one. Now I want to go to teaspoons per day. So my teaspoons is good. I just need to convert that dose to day. So I'm going to keep going. Dose is on the bottom. So I'm going to put dose on the top. And I want to put day on the bottom. How many doses per day? Well, I don't really have that, right? So I can't really put day at the bottom. So what should I put? Well, I remembered over here, I have in 1 dose every 6 hours. Then I can convert and say, I know hours on the top. I know there are 24 hours in 1 day. So my hours cancel, and I'm going to put my answer down here. And so what I'm going to get is 8 teaspoons per day, right? And so that is let's see, blue, we haven't done blue. Teaspoons per day, teaspoons per day. So just make sure that you track everything that you're doing, you write it all out, do whatever you need to do. Okay, let's do the next one. I'm gonna kind of cut this out so that I can keep going. Okay. All right. So now the doctor's telling us give drug X in 3.0 micrograms per kilogram per day in 2 divided doses. The patient weighs 22 pounds. How many milligrams should be given per dose and per day? Whew. Okay. What's our goal and what do we know? So number one, our goal is that we want to know how many milligrams should be given per dose, and then we want to know how many milligrams should be given per day. Second thing is we're going to pull out information. Give drug X in 3.0 milligrams per kilogram per day, right? So this is how much medicine they're going to get per day. You write it that way. You could, if you had room, you could write it this way. Doesn't matter if you have room. I don't have room. So then in 2 divided doses. So each day the person's going to get 2 doses. So there are 2 doses per day. And the patient weighs 22 pounds. The first thing I look at and I say is my patient is in pounds. That is not going to be good. So I really need to get rid of that. So the first thing I'm going to do is I'm going to convert that pounds to kilograms. So the person was 22 pounds. Okay, so if I want to get rid of pounds, I want to go to kilograms. What do I do? So I'm going to go to my best friend over here and I'm going to say, okay, right here is my kilograms to pounds. In 1 kilogram, I have 2.20 pounds. So what's the mass of my my patient here? And that's going to be 10 kilograms, right? Okay, so now I can kind of use that information and keep going. So I want to go back and say, where do I start? So 22 pounds, and we're going to kind of cross that out. And we're going to say the person is 10 kilograms because we're going to kind of need that. Okay. So I'm going to start with whatever the doctor prescribed. The doctor told me to give this person 3.0 milligrams per kilogram. So I need to say, how much does the person get? Well, in order to do that, I'm going to have to multiply by however much they weigh. So if it's 3 milligrams per kilogram and they weigh 10 kilograms, that is 30 milligrams of medicine that person should be getting. And they told us that they should get that amount of medicine each day. So that should be 30 milligrams per day. So that's what we did there. So we used all that information. We used this information. So how many milligrams should be given per dose? Well, this is my milligrams per day, right? But the question is really how many milligrams per dose. That was my first one. Oh, but this one, look, this one of my goals is how many milligrams per day. Well, what did I just figure out? Milligrams per day. Okay, so I got one of them done. Woohoo, right? I'm halfway there. So now I'm going to try and get to this goal, my milligrams per dose. So let's see if we can do that. All right. So I want to keep my milligrams. That's correct. I want to change my dose. So I'm going to put day here. And look at this. I have this beautiful conversion factor that takes from days to doses. So in 1 day, they're going to get 2 doses. So what should they get? They should get 15 milligrams per, my days cancel, per dose. And so indeed, my units match right here. So we've answered the question. So just take it piece by piece by piece, right? Okay. Let's see if I can just take this one down here. Okay. A child who weighs, we're going to put 1, we're going to put 2. That's our 1's our goal. And then 2 is what we know. And I'm going to kind of pull this out as I go. A child who weighs 66 pounds is receiving a dose. So in one dose, they're getting 125 milligrams of drug 3 times a day. So they're going to get 3 doses per day. The safe range is 10 to 20 milligrams per kilogram per day. Is the child receiving a safe dose? Okay. So what's our goal? What do we want to get to? We want to know if are we dosing this kid correctly? So let's try to figure out what the child is getting, and we'll figure out if this fits along in our safe range. So the goal is to find out how much we're giving the kid, this kid, what's their dosage? How many milligrams per kilogram per day are they getting, right? Okay, so let's set up our dimensional analysis. What do we know? Well, we know that I'm giving this kid 125 milligrams. And the reason I'm swapping this, why did I move milligrams to the top? Because my goal milligrams is on the top, okay? So I'm giving this kid 125 milligrams per dose. Well, that's interesting, but that's not the unit that I really want, right? What I want to know is how many milligrams they're getting per day, and then we'll look at giving it, how many we're giving total milligrams because of their weight, right? If they weigh 66 pounds, we know that we're going to have to convert that. 66 pounds, we convert that to kilograms. Pounds, we know we have 2.20 pounds in 1 kilogram. So 66 divided by 2.2, 66. I don't know why I thought it was 6.6. Divided by 2.2 gives us 30. So we have 30 kilogram kid, right? So what we can do is we can say, we're supposed to give them 125 milligrams per dose. So we want to get rid of dose because that's not in our thing, and we want to go to kilograms. So we know our kid is 30 kilograms. So we can convert that. Hold on, y'all. So we have 125 milligrams per dose. We don't want per dose. We want how many milligrams per day that we are getting. And then we're going to work in the kid's weight. So if we want to get rid of dose, we're going to put dose on the top. And we have a conversion here that gives us 3 doses per day, per 1 day. So that tells us 125 times 3, we get 375 milligrams per day. So that's how much this kid is getting. But in the problem, right, we're only saying that we have this safe range at 10 to 20 milligrams per kilogram per day. So this is just how much they're getting per day. That doesn't tell me how much per body mass. So you have to include that 375 milligrams per their 30 kilograms, that's what we calculated, per day. So now all you have to do is simplify this top portion here. So 375 divided by 30, we get 12.5, and then just keep all of these units, milligrams per kilogram per day. So is this safe? Well, what did they say is safe? Safe is 10 to 20 milligrams per kilogram per day. This kid is safe. Yay, we are going to keep our patient. Yes. Okay, so let me copy this and pull this down so that I can do it down here. Paste. Okay. All right. So what is the amount of fluid that is left in a 1,000 milliliter IV that's been running at 21 drops per minute for 70 minutes? Assume 20 drops per ml. Okay. What's my goal? Number one, what's my goal? What is the amount of fluid left? So if I'm talking about amount of fluid left, what unit is that going to be in? That unit is going to be in milliliters. Okay, that's my unit. But be careful, this is kind of a weird one because it's asking what is the amount of fluid left? What do we know? That we start with 1,000 milliliters in our IV, right? We know that it has been running at 21 drops per minute, and it's been running for 70 minutes. And we're going to assume 20 drops per ml. So what do? How do we set this up? For me, when I see this, this is my step 3. My final answer, I want to be in only a numerator unit, and I only have one other thing that starts as just one unit. It doesn't have a top and a bottom, doesn't have a numerator and a denominator. So that's what I'm going to start with. I'm going to say this IV has been running for 70 minutes. Okay. And I want to go to milliliters. So where else do I see minutes? Right. I'm going to cross that out because I used it. I see minutes right here. So in 1 minute, I know that I'm going to produce in that IV 21 drops. So I use that. My minutes cancel, but I'm not in the unit I want milliliters. So I have to go to my other piece of information, and I know that there are 20 drops in 1 milliliter. So I've used that. My drops cancel. I'm in my goal unit. That's great. So that should be, if you calculate it, it should be 74 milliliters. Does this answer my question? Not quite. This is telling me how much has gone through the IV. So it's 74 milliliters that were used. But is that what the question is really asking me? It's really asking me how many milliliters are left. So if I start with 1,000 milliliters and I use 74 milliliters, all I have to do is subtract the two. And if I subtract the two, I get 930 milliliters, and that's how much I have left. And double check your sig figs, 2 sig figs. This should be, we're just going to assume 2 sig figs, okay? Because really, you need at least 2 sig figs. Okay, I got to copy these other problems. Okay, number 8. But number 8 right there. Ooh, that's small. Okay. A patient is admitted for asthma, and the physician's order reads, oh my goodness. Okay, so we might start with not the goal, but pieces of information that are given. So start our drug, and do you have to be able to say the drug? No. But at 1.2, oh my gosh, 1.2 milligrams per, and per can either be a slash or you can write it like this, milligrams per kilogram per hour. And the IV is mixed, so you have 500 milligrams per 1,000 milliliters of saline. We know our patient weighs 132 pounds. Anytime I see pounds here, man, it drives me bananas. So I just go ahead and convert it right here, pounds, and we know we want to go to kilograms. So I know I have 2.2 pounds and 1 kilogram. So that's 132 divided by 2.2, and we get 60 kilograms. Okay, so now I kind of just have that as my piece of information. So my goal is how many milligrams per hour do I give, and how many milliliters per hour do you give? Be careful that it's the top unit that is different in this problem rather than the other unit, the bottom unit. Okay, so what do I start with? Well, I'm going to say, okay, I'm going to start with how much this patient weighs. And so I'm going to start over here with this kilogram. So I have 60 kilograms, right? That's my patient. And I want to go from kilograms to milligrams, right? Really milligrams per what? What do I have here? So if I have kilograms, if I put kilograms here, this kind of goes together, kilograms per hour. So I'm just going to go kilograms per hour. And then I'm going to put milligrams on top. So I have 1.2 milligrams per 1 kilogram per hour. So my kilograms cancels. And what am I left in? I'm left in, whatever's left is milligrams per hour. And so 60 times 1.2 should give me 72. So I have 72 milligrams per hour. Now I need to know how many milliliters per hour. So this one's answer is right there. I'm just going to keep working. And I'm going to say, okay, well, I need to convert. And so I want to get rid of my milligrams. So my milligrams is going to go on the bottom. And I want to go to milliliters. Do I have a conversion factor that will allow me to do that? And I do right here. And so I have 500 milligrams per 1,000 milliliters. And so my milligrams will cancel, and I get 140 milliliters per hour. And so that is my milliliters per hour, and I'm good. You just got to practice. The more you do, the better you're going to get. And remember to practice these without looking at the answer. Okay, copy that. I'm going to come all the way down here, paste it right there. Okay. The body contains about 5 liters of blood. Blood contains cellular elements, about 45%, and plasma, 55%. How much plasma is in the blood? So all you're trying to do is basically convert, right, from a decimal to a percentage. So if I know I'm looking for plasma, and we know we have 55% plasma. So all I have to do is convert that percent to a decimal. So I know 55%, if I convert that to a decimal, all I do is divide by 100 and I get 0.55. And then I say, okay, I had a total of 5 liters of blood times whatever fraction is plasma, and I get 3 liters. Here I'm not trying to change units, right? This was kind of a different kind of problem of plasma, right? And you really only had 1 sig fig, so your answer should only be 1 sig fig. Okay, I hope that helps.